Welcome back to the Deep Dives. Today we're diving into the often overlooked but super crucial preliminary considerations in operative dentistry.
Yeah, it's like we're laying the foundation for those beautiful restorations we all strive for.
Exactly. And speaking of foundations, I was blown away by how much complexity there is with something as seemingly simple as a dental matrix. I always thought it was just, a basic mold.
Right, but it's so much more than that. It's like, think of it as a tiny temporary wall that helps us rebuild a tooth with the perfect shape and those all-important contact points.
Those contact points, they're crucial, right? I mean, we'll get into that later, but just thinking about the matrix itself, I mean, there are so many different types.
Oh yeah, tons. And each one has like its own strengths and weaknesses depending on the situation. You've got your classic Toffelmeier matrix.
Oh, yeah, the Toffelmeier.
Mm.
But I read it's not always ideal for composite fillings.
Well, it's versatile, no doubt. But composites, they shrink as they set. And if the matrix doesn't accommodate for that shrinkage, you can end up with gaps or an uneven surface.
Ah, I see. So it's like trying to fit a square peg in a round hole.
Yeah.
Sometimes you need a more specialized tool.
Exactly. And that's where those other matrix systems come in, like the Automatrix. Have you heard of that one?
I have. It sounds pretty high-tech.
It is. It's retainerless, so you don't need those bulky rings and clamps. Gives you way better visibility, especially in those hard-to-reach areas.
That makes a lot of sense. And what about the S-shaped matrix?
The S-shaped matrix. It's pre-contoured into this unique shape, right? And that makes it perfect for those really tricky slot preparations or restorations on those, like, canine teeth.
So many options.
Yeah.
But no matter what type of matrix we're using, are there some, key properties that we're always looking for to make it effective?
Definitely. You need a matrix that's rigid enough to withstand the pressure when you're condensing that filling material, but also flexible enough to create those precise contacts with the neighboring teeth.
So it's like a delicate balancing act.
Exactly. And of course, it should be easy to place and remove without damaging that surrounding gum tissue.
All right, got to be gentle with those gums. Okay, let's shift gears a bit and talk about something that always makes me a little nervous. Drill speeds.
Ah, yes.
Yeah.
Drill speeds. I bet you think faster equals more pain, right?
I do. But I was reading that that's actually a myth.
Yeah, it's a common misconception. High-speed drilling, yeah, it can sound kind of scary, but it can actually be more comfortable for the patient in the long run.
Really? How so?
Well, it allows for lighter pressure and shorter procedure times. Less vibration, too, which means the whole experience is less traumatic.
That's reassuring.
Hmm.
So let's break down those speeds a bit further. We've got low, medium, and high measured in those revolutions per minute.
Right, RPMs.
What's the purpose of each range?
Okay, so low speed, that's your precision instrument.
Mm-hmm.
Think delicate decay removal or polishing up that final restoration. It's all about finesse and minimizing how invasive we are.
Makes sense. And medium speed.
Medium speed offers a bit more power. It's ideal for refining the shape of the cavity or creating those little retention features.
Yeah.
That way the filling material really grips on.
Ah, okay. So then high speed, that's where things get really intense.
High speed is where those powerful air-driven turbines come in. You're talking like 200,000 RPM or more.
Wow. And what do we use high speed for?
It's mainly for cutting through enamel in those old restorations. It's very efficient.
But are there any downsides to high speed? Aside from the fear factor, I mean.
Well, it's a powerful tool. It needs to be controlled carefully. One thing is it can remove tooth structure more quickly, so there's a risk of removing too much if you're not careful.
So precision is key.
Absolutely. And the air and water spray used for cooling, it can sometimes obscure your view, so you really need to pay attention.
That makes sense. So it's all about balancing efficiency with precision then.
Exactly. And sometimes you need to step away from those high-speed rotary instruments and go back to those classic hand instruments.
Oh, yeah, those are still important, right?
Absolutely essential. They offer a level of finesse and tactile feedback that you just can't get with rotary instruments.
So when would you choose a hand instrument over a rotary instrument?
Think about tasks like precisely removing weakened enamel or really meticulously shaping the edges of a filling. That's where hand instruments really shine.
Okay, so let's talk about some of those hand instruments and what makes them unique. What are the key parts and how do they all work together?
Well, you've got the handle, of course. That's what gives us a good grip. Then there's the shank, which connects the handle to the working end. And then, of course, you have the blade, which is the heart of the instrument.
And that blade, it has a carefully angled cutting edge, right?
Exactly. And each element, the handle, the shank, the blade, they all contribute to how the instrument functions and how it feels in our hand.
It's all about that precision control. Now, I came across this term, Instrument formula, and it sounds very technical. What is that all about?
Ah, the instrument formula. That's a numerical code that was developed by G.V. Black. He was a real pioneer in dentistry.
And what does this code tell us?
It describes the precise dimensions and angles of that hand instrument's working end. It's kind of like a secret language that lets us pick the perfect instrument for each specific task.
Wow, that's amazing. So can you give us some examples of these essential hand instruments and what makes them so special?
Sure. So we have the enamel hatchet. It's designed specifically for cleaving or splitting undermined enamel. Think of it like a tiny little axe.
That's a great visual.
It allows us to remove that weakened enamel in a very controlled way without harming the surrounding healthy tooth structure.
That's crucial. And what about the gingival margin trimmer?
Ah, the GMT. That's a modified enamel hatchet with a curved blade and a unique cutting edge. We use it to create bevels.
Bevels.
Yeah, those are the subtle angled edges that make sure there's a smooth transition between the filling material and the tooth.
It's incredible how much thought goes into even the seemingly simple act of removing tooth structure.
It's all about preserving as much healthy tooth structure as possible.
Now let's move on to another crucial step in operative dentistry: tooth separation. It sounds a bit scary, to be honest. How do we create space between teeth without causing too much discomfort?
There are two main approaches to tooth separation: rapid and slow. With rapid separation, we need that space immediately, usually during a single appointment.
Okay, so how do you do that?
It usually involves using wedges, those little triangular helpers, or mechanical separators like the Elliott separator.
And the Elliott separator, how does that work?
It gently pushes the teeth apart using a spring-loaded mechanism.
Interesting. And what about slow separation? Is that more like orthodontics?
It can be. Slow separation gradually moves the teeth over a longer period of time, like days or even weeks.
So how do you accomplish that?
We might use things like rubber bands, orthodontic appliances, or even oversized temporary crowns. It's a slower, gentler approach.
Makes sense. So before we wrap up part one, I want to go back to those wedges you mentioned. Are there different kinds, and how do you decide which one to use?
Oh yeah, there's a whole world of wedges out there. We have wooden wedges, which are easy to adjust and absorb moisture, swelling a bit, to make a nice snug fit.
And what about shapes?
Triangular wedges are great for reaching below the gum line, and round ones are good for more standard restorations. Then we have plastic wedges, and some are even see-through. Those are perfect for composite fillings, where you need to shine a light to cure the material.
I had no idea there was so much to those tiny little wedges. Join us for part two, where we'll delve into the world of burrs and diamonds, the heavy hitters of cavity preparation, and explore how we achieve those perfect contact points.
Welcome back to our deep dive.
Last time we were talking all about those matrices and wedges and those different drill speeds.
Yeah, the foundations, right. So now we're getting into those burrs and diamonds, the workhorses of cavity preparation.
Yeah, the tools that make that whirring sound we all know from the dentist chair. But like we talked about, it's not just about drilling fast.
Right, it's about choosing the right tool for the job, whether it's a burr or a diamond. And they each have like specific strengths and weaknesses.
So what's the main difference between a burr and a diamond? They're both rotary instruments, but I'm guessing there's some key distinctions.
You got it. The main difference is in how they cut. Burrs, which are usually made of steel or tungsten carbide, have those sharp blades that, chisel away at the tooth structure.
And I'm guessing those tungsten carbide burrs are the tougher ones.
Oh, for sure. Way more durable than steel burrs. They can handle those higher speeds without dulling as quickly. Think of it as the difference between a butter knife and a chef's knife.
That's a great analogy. So tungsten carbide burrs are like those heavy-duty tools for removing larger amounts of tooth structure, especially when you're working with enamel.
Exactly. Now, diamonds, they're in a whole other category.
Yeah, diamonds are known for their hardness. So does that mean they're even more powerful than carbide burrs?
Not necessarily more powerful, but they've got these unique properties that make them perfect for certain tasks. Diamonds, instead of blades, they have these tiny abrasive particles embedded in their surface.
So it's more like sandpaper than a knife.
Yeah, you got it. Diamonds, they grind away tooth structure. They're awesome at cutting enamel with incredible precision, and they're also really good at smoothing and refining those cavity preps.
Interesting. So each has its own purpose. It's like a dentist's toolbox,
Exactly. You've got the right tool for every situation. Okay, let's talk about burr shapes now. Have you ever looked at all the different burr shapes?
I have. It's mind-boggling. Round, straight fissure, inverted cone.
Yeah, there are so many, and they each have a very specific purpose.
So the shape of the burr head, that determines how it interacts with the tooth. Like, I'm guessing those round burrs are used for, well,